Hey there, grade 8s. Welcome to another home edition of math. In today's lesson, we are doing lesson 5.6, or chapter 5, lesson 6, and we are talking about equivalent ratios. So I touched on this a little bit last day, and we're going to expand into it a little bit more. So I've got an example here. So here we've got two what we would call equivalent ratios, and this is a lot to do with fractions as well. So they kind of relate. If you're struggling with fractions, hopefully you're paying a lot of attention here, and we're going to try to hopefully ease people's minds. When we're talking about equivalent fractions, this is what we have going on. So if we're comparing, let's go triangles to circles. Okay, so we have in this one 4 triangles to our 3 circles, whereas when we go down here, we have 8 triangles compared to our 6 circles. Okay, so we're going to use this one a little bit more. So these are what we call equivalent fractions. Why is it equivalent? Well, they have the same value. So basically what we're saying is for every time that we have 4 triangles, we are going to have 3 circles. Okay, so if I look down here, I have 4 triangles, 3 circles, 4 triangles, 3 circles. So if I was to continue this pattern, if I had 12 triangles, okay, then I would have 9 circles. All right, so I'm going to jump into just something a little bit more. So if we have that ratio, okay, if we have that ratio, so I'm going to take those 2 that we had. So we had 4 to 3, okay? Underneath it, I had 8 to 6. So what happened here? I took this and I multiplied it by 2. I took this and I multiplied it by 2, okay? I can do the same thing, but now I can, let's say if I jump it up and I jump it to 3. So I take 4 times 3 is going to be 12. 3 times 3 is going to be 9. So now this jump that it brings me to here is times 3. This one brought me here was times 3 from my original numbers. So these right here is what I'm talking about from my original. What if I was to multiply it by 4? Well, I'd get 16. Okay, so this would be times 4. 3 times 4 is going to give me 12. So this is times 4. I can do it times 5. So this is going to give me 20 times 5. 3 times 5 is 15 times 5. So all of these are considered what we would call equivalent ratios. Okay, I can go the other way too. Okay, what if I divide by 2? Well, 4 divided by 2 is 2. Okay, 3 divided by 2 is going to give me 1.5. So if I'm going the other way now I'm going divided by 2. Okay, I'm going divided by 2. What if I wanted to divide it by 4? Well, 4 divided by 4 is 1. Okay, 3 divided by 4 is 0.75. So to get to here, I had to go divided by 4. Okay, so I can go different ways. So like I was talking about, when we have fractions, well, like I've mentioned previously, we don't really want to have a decimal when we have a fraction. But when we have ratios, we technically can. Is it easy? No, not necessarily. It's not as easy or simple for us to look at and understand what is actually going on in that situation. But what we can see is that the ratio or the comparison between each of them is the same. Okay. All right. So a couple questions for you guys. Oh, here's my cloth. For you guys just to practice. So you're gonna pause the video and just give me some of your possible answers. So I want you to find three ratios that are equivalent to 2 to 5. Okay. I have 2 to 5. Give me 3. Any 3. I'm gonna write down a couple that you guys could have. All right, so hopefully you pause the video if you didn't do it now, and then just give it a go. So one that I could do is 4 to 10. I could also I could multiply it by 3, and I could have 6 to 15. I could multiply it by 4, and I could have 8 to 20. I could multiply it by 10 and have 20 to 50. I could multiply it by 100 and have 200 to 500. You know, any one of those possibilities. I could have had 1 to 2.5. Okay. Any possible, there's tons and tons and tons of possible solutions that you guys could have had. So hopefully you were able to get that one. All right, let's try another one. All right, once again, I want you to give me 3 possible solutions to 36 to 6. Okay, 36 to 6. Give me what your possible solutions might be. Okay, hopefully you've paused it. So what I might do is I might divide them by 2. So I might have 18 to 3. Okay, I might divide them by 3, which would give me 12 to 2. I might divide them by 6, which would give me 6 to 1. I might multiply them by 2, which would give me 72 to 12. Okay, I could multiply them by 10, which would give me 360 to 60. Okay, there's tons and tons and tons of possible solutions. Okay, so hopefully you were able to find a couple of those. Okay, so hopefully this is starting to make a little bit of sense. It's similar to when we're doing equivalent fractions, where your goal is just to find numbers that they can both be multiplied by. Okay, just a reminder, like I always say, math is always fair. So what you do to one, you need to do to the other. So if you multiply one number by 2, you have to multiply the other number by 2. Or if you divide it by 3, you have to divide the other number by 3. Okay. So if you guys have any questions at all, make sure that you bring those questions to the Zoom, and then hopefully we can try to work on those together. Good luck.